else you see like from Europe to from America to Africa, there's not that much. From Asia to Africa, there's not that much. For America to Africa, there's not. I mean, you can see that we have hardly direct link from North America to Africa, but between America and Europe, you have a lot. So we can tell, we can guess why.
Okay, my name is Ezra. I think most of the infrastructures,
Okay.
the internet infrastructures are based on those two continents, America and then Europe. That's why.
Okay, this is what you think. Cool. Another one. Who else wants to try? Who else wants to guess?
Thank you very much. I also think that there are a lot of internet users in that region as compared to the other regions.
Okay. Okay.
One more.
So thank you for your responses. Now let me put it in this way. Let's imagine that between Accra and Takoradi, or Accra and let's say Kumasi, right? Accra and Kumasi. Between Accra and Kumasi, we see that we have like 10 cars using the road every let's say every hour. Each hour we have 10 cars. And we realized that like some month later, we have like 1,000 cars every hours. So what's going to happen? It's going to have huge, we are going to have huge traffic, right? So the government may say, hey, we need to build a motorway. And when we build the motorway, we see that because we have a lot of business between Accra and Kumasi, it's now 10,000 cars because they see that, okay, we have motorway so we can do the business. So what's going to happen? The government is going to create another motorway, etc., etc., etc. So these cables are related to the data that are crossing between America and Europe because there are a lot of data. There are a lot of content that are crossing, that are passing between those two continents. This is the reason why there is a need to build a lot of cables to be able to accommodate this huge traffic that are between uh, um, Europe and America, compared to Africa, where we don't have a lot of content. So that's the reason why they say, okay, those guys in Africa, they put their content here in America, they put their content here in Europe. So there's no need for us to build cable to go and get those contents. We are all on the social media. We are all connecting on those, but most of the time, the data that we are the content that we have, we put them directly in their data system, the data center. We put them in the US, we put them in Europe. So this is why they don't see the need for them to come and get things because there's nothing for them to come and get in Africa. So we want this to change. We need to develop content and store this content in Africa. So this is one point. So this is the reason why those two continents have a lot of, because of the huge amount of data that are crossing all the time between those two governments. And this is very important. This is one of the a point that we are now working on when we are talking about internet governance. We are talking about content, local content, build data center. You can see that we have a lot of programs like WADI, for instance, that is helping African countries to create data center, that is encouraging African countries to host the data in Africa. So this is the first point. Now, after the backbone, the internet backbone, what the question that we can ask is, what are those organizations? What are those people that are building those this internet backbone? So they are called the internet service providers, and we have three types of internet service providers. Most of the time, when we say internet service provider, we say, okay, this MTN, this Orange, this Glow, this is my internet service provider, etc., etc. But we have three types of internet service provider. We have the tier one and the tier two that are called internet bandwidth providers, IBP. We call it the internet bandwidth provider because they are mainly the ones that are creating all those cables, and especially tier one, they are giving access to the rest of the world to a given internet service provider, to a given tier two or tier three. The tier three are what we know. like MTN, Orange, MTEL, Glo, Vodacom, etc., etc. Those are what we are calling the tier three. That are the internet service provider that we have in our country. We take the CP, we take the internet. Yeah, so they are the one that we are calling the tier three. So these we are used to the tier three, but the tier three are used to tier two and tier one because they are the ones that are giving them access to the internet. So it's very important. Now, there are some examples of some of those tier one. So we have AT&T, CenturyLink, Dutch Telecom, Global Carrier, Orange, Open Transit, Liberties, Global PCCW, Global Tata Communication. I put like a few of them, but today we have many of them, and we have some African countries that are building now today. They are working together to build like cables, submarine cable to connect the countries to the country to each other. So we have many people, many organizations that are working in this area as well. And some of the key elements that we have is number one, they own the portion of the internet. So if they don't pay, like AT&T is not going to pay to connect to CenturyLink. They are not going to pay. They are doing what we are calling peering. So they say, you look, I have connectivity in Africa, but you have connectivity in Asia. Me, I want to connect Asia. I see that you don't have connectivity in Africa, so let's use our roads. So they do peering and they share the transit, they share the road, and they can access. So they don't pay the own portion of the internet. They then don't need to pay, and they can read everywhere without paying that. And the number three is one of the points that are currently table on the internet governance sometimes is there is no authority like body like the regulator that dictate rules there. It's open. There is nothing like ICT regulator that we currently have in our countries. At this level, there is nothing. And people are questioning whether we should not like find a mechanism where we should regulate them, etc., etc. But it's going to be very complicated because the bid it's a lot of money to build the and a submarine cable, and it's like it's not easy. Now they are in the position to dictate prices. So this is why at some point they say why maybe the World Trade Organization might not have a look into what they are doing, etc., etc. But yeah, there are things that people are discussing. And now the tier two and the tier three. So now you know that we have we have three types of internet service providers: tier one, tier two, and tier three. And we have what we are calling the internet bandwidth provider that are tier one mainly and also tier two. And now let's focus on the tier two. So the tier two and the tier three, now focus on the tier three, sorry. The tier three, most of the time, they pay to access the internet backbone. Because I don't have enough money to build my own cable from like Ghana to the rest of the world, I'm going to pay, a tier one or a tier two to give me this access. And I'm going to pay for the bandwidth. I say, okay, I want 1 terabit, I want 10 terabits, etc., etc. I'm going to pay for that. I'm also going to pay for my membership because I need IP numbers to connect my network and my devices and my customer to the internet. We're going to discuss about it. And I have to comply with regulatory policies. And here elsewhere, I need to pay my license. And the telecom licenses are very expensive. And this is where, at the end of the day, we are we customers we come into the game because all those fees have to be borne by the customers that we are. So you can see that the price of the internet in our countries depends on all those points. And we also have the staff, etc., etc., etc. So internet is cheaper in some countries, it's expensive in some other countries, depending of how the internet technical ecosystem have organized in this country and how many cables lands there, and we have many uh, elements that uh, have to be taken into consideration to think about internet pricing. Now that we have the backbone, that we know that we have tier 1, tier 2, tier 3, now we know that with a backbone, there is no internet. Each network will select it. Thanks to the backbone, all the networks are interconnected. Now we say that, okay, we are going to use internet. We need to agree in what what are the rules that we are going to use while using this internet. So this is what we are calling protocols. This is what we are calling the protocol suites. Internet protocol suite are rules that we use to be able to exchange traffic regardless the devices, regardless the location where we are from. So today we say that we are going to do Ghana IGF, and then imagine I start speaking French. French is not the standard in this, for this session. If I start speaking French, people will be like, we don't know what this guy is talking about. So the standard into this class is English, sorry. So this is the same thing for the internet. We say, okay, we are going to use the internet, so we need to define what are the rules that we are going to use to be able to communicate. So this is the role of these standards. And we have many organizations. I put here some of them. One of the oldest standard organization is ITU, Internet Telecommunication Union. That is the oldest one. And after that, we have ITF, we have IEEE, and ITU, etc., 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 etc. So we have many organizations that are working to create standards that can be used on the internet. So we have the backbone, we have the Internet Protocol Suite, and then let's go to the numbers now. We have a lot of networks on the internet, and we might find a way to identify each of them. To do that, we are using the autonomous system numbers, ASN. So each autonomous system number must be identified on the internet. It's not optional. Like if you want to connect to the internet, you must have autonomous system number. Like when I'm in Accra, if I want to visit my friend, I need to know where a friend stays. I have to know the location of the house, the road, the etc. etc. So at some point, I need to have details on how to get there. So this the role of ASN. So ASN is there to tell the world that this is my network, and if you want to get to me, this is how you should be doing. And we have two types of ASN. So we have the 16 bits that have been exhausted. So you are now issuing ASN from the 32 bits version. Okay. So again, each network on the internet have to be identified, has to be identified with something that we call an autonomous system number. Now, all those are networks, right? Now, inside the network, what we have a lot of devices. We have computers, we have like switches, we have routers, we have servers, we have TVs, we have everything in our house. You say today with Internet of the Thing or an Internet of everything, everything can be connected to the internet. And each of those things must be identified on the internet as well with a number that we are calling IP addresses. We have IPv4, we also have two versions. We have IPv4 addresses and we have IPv6 addresses. As you can see, the IPv6 is kind of long, right? And we have the IPv4 that is here. Okay, so when you are browsing the internet right now, because I'm connecting to you guys, my device is identified with an IP, a public IP address, IPv4 and or IPv6 address. Those who are connected right now in this class over and the phone, the tablet, the computer, the laptop, whatever you want, to the internet, those devices are identified with an IP address. It's a must. It's not something that is optional. So we must have an IP address for on a device to be connected to the internet. We must have a autonomous system number for a network to be connected, to be visible and connected to the internet. And this is the most. So this is why we say that with no IP, we don't have internet. When we are talking about e-governance, without IP, you can do e-governance. Without IP, you can give fintech. Without IP, you can give e-health. etc., etc., etc. This is why IPs are extremely important in what we are doing. Okay, you can have the backbone, but if you don't have IP, your network can't be and your devices can't be visible on the internet. So no devices without IP, we don't have internet. Now, because like they are the machines understand numbers. So if you have um, like in your phone, if you write the name like if you write my name in your phone and you want to call Brice Abba, your phone won't be able to do that. So we need to have a big book. The DNS is like the a phone book, where name match a number. So this is it. That's the role of the DNS. And because we human can remember numbers, a lot of numbers, but we can easily remember names. This is why it make very to have DNS system in place. And well, DNS is extremely important for human because we are the ones that are using the internet. But for devices, for machine, DNS is not important because without DNS, we can still, if you know the IP number, you can still reach those websites. But at the end of the day, you can't be able to remember all the IP addresses of each of the websites that you want to browse to. So this is why the DNS is playing a crucial role in the internet for human because internet is made has been built for human, right? So like if you have DNS issue and you are a technical person like me, like technical, you can always find your way. But if you don't have IP, you are done. Okay, you are done. So it's very important. So internet has a lot of elements, but I wanted to put those 4 elements like the backbone, the protocol suites, the resources, the IP number resources, IPv4, IPv6, and autonomous system numbers, and the DNS. But remember that we have many elements that are in the internet, but those 4 are very important. Now, let's me explain you how you get internet reach us at home. So we have this customer that this customer one. I go to my internet service provider. I say, hey, I want to buy like an option like internet connection access. I want an internet connection, internet access to your from your system. My internet service provider is going to give me a device that we call a CPE. Okay, so this small router that we use that the internet service provider bring to your home where it connects, everything for you to be able to connect with over Wi-Fi, etc., etc. This device allows you to connect to the access network of your internet service provider. This is the number one, access network. So the access network use what we are calling access technology. Access technology. And what are the access technology? We have 4G, 2G, LTE, 5G. So you see all those technology that we are calling access technology. 5G, fiber to the home, FTTH, GPON, etc., etc., etc. So all those technology that we know are called access technology. So they basically connect your home to the access network of your internet service provider. Now, when you are connected to your network, what is going to happen? The data that you are sending will go to connect from your router to the internet access network of your internet service provider. Your packet is going to connect to the core network of your ISP and then connect to one pop of a tier 1 and then get to the internet. So this is how internet gets us at home. And each time my internet service provider is using this international link, is being charged by the internet bandwidth provider. So as soon as a packet is using this link, a charge is created. We have to pay. So this is why we are talking about internet exchange points. Because see, my neighbor here, we are neighbor. It's like, and I can even, open my door and call my neighbor back because I don't want to do that. I'm saying, let me test him. When I send you a text on WhatsApp, my text is going to leave my network, connect to the access network of my internet service provider, get to the core network of our internet service provider, go to the tier 2, for instance, go to the pop of the tier 1, go to the internet. You see, I'm going to be charged for that. My internet service provider is going to be charged because I'm using this link. Then connect to the tier 1, the pop of the tier 1 of my neighbor internet service provider. Okay, and it's going to pass through the core network, then the access network, and finally to my neighbor. So you see, this is the road, this is the route that this packet used from my neighbor house to the internet, to and it goes back to my network. But this situation, we can change that. We can find a way to change this, to make this route more shorter by creating what we are calling an internet exchange point. So what is going to happen? When we are internet service providers and we are staying in the same country, we create a physical connection, like a level 2 connection, where we decide to connect. So this ISP1 is going to connect to this internet exchange point. This ISP2 is going also to connect on to this internet exchange point. So here we say that all the local traffics, like when, let's say, University of Accra wants to communicate to University of Tema, for instance, they are staying in the same country. So what is going to happen is like the net information that's from the University of black, white, black. So this network, that University of Accra, who wants to send a packet to University of Tema, is going to send the packet like this through his internet service provider. From his core network, the packet will be routed to the internet exchange point, because we have the information that those two entities, those two universities, are in Ghana, and they are using internet service provider that are connecting onto this same point that we are calling internet exchange point. So here we are going to connect all local traffic here to ensure that local traffic remain local. And then the packet will go back to the University of Tema. That is going to be the same thing. These two neighbors that used to use international link here with WhatsApp or with Facebook or wherever you want, will stop using the international link, and they will use this link that I've created in Ghana. And in Ghana, you have an internet exchange point. So the idea here is to avoid or to rate the use of the international connections much as possible. So if my internet service provider is paying less here, my internet invoice is going to drop. Okay, so this is the reason why we encourage our countries, our technical community, to invest the internet exchange point that we used to call XP. Okay, so I have to get the point. So this is how internet reach us at home, and we have an option to keep local traffic local to avoid using international link, and that helps us reduce internet cost. Now, let's talk about how those numbers are managed. I explained that internet is many elements, but are focused on four elements: the backbone, the internet protocol suite, the internet number, resources, IPv4, IPv6, autonomous system numbers, and I talked about the DNS. And I explained that to get internet at home, we need to have internet service provider. You need to use access technology to connect to the access network to our ISP, and from there, the packet is going to go through the core network to the international connection, etc., etc. Now we are going to talk about how those IPs are managed. The first element is what we are calling the area system. Area stands for regional internet registries. So we have 5, but in the beginning there were fewer than that, and Africa was split. Africa was like divided in 3. Okay, as usual, we were divided, but since 2005 that we have been recognized by ICANN, we have been accredited as a regional internet registry by ICANN. Africa has now its own internet registry. So we have 5, as you can see, and we have 3 core functions. 3. So A, the first core function of all the internet resource, internet number, regional internet registry, are to allocate IP numbers. IP numbers allocation. IPv4, IPv6 autonomous system number. B, ensure those IP are unique by maintaining a data center. That is part of the management of those IP that we are issuing. Okay, we have a database that stores all the IPs that we have been assigning to our members. Number 2, ensure that IP that you are giving are unique worldwide. And point 3, C, because internet is bottom-up process, coordinate resource policy within the region. So each time AFRINIC is giving an IP address to an organization in Ghana, AFRINIC is checking the book that the community wrote for AFRINIC, that we are calling the policy. And this book is called the CPM, Consolidated Policy Manual, that you can find on AFRINIC website. The community has decided what AFRINIC should do when they receive a request. If somebody wants an IPv4, this is how you should proceed. If somebody wants an IPv6, this is how you proceed, etc., etc., etc. So we coordinate the resource policy regionally, we manage IP numbers over a database, and we allocate IP numbers. So those are the 3 core functions of all the 5 areas. And next to those main functions, we have a lot of initiatives that we are doing. We have internet governance, we have security, we have capacity building, etc., etc. But those are the 3 core functions that we are all having here. Now, AFRINIC at a glance. So we have been the last one to be created. As you can see, we are 43 full-time staff. We are covering all the African countries, including Indian Ocean. Okay. Last, for instance, Mayotte, who is in France, who is basically France, is also covered by AFRINIC. So Mayotte can get IP from AFRINIC and from RIPE CC as well. We have Mauritius, we have Seychelles, we have, some countries, we have also Madagascar, we have some kind of Indian Ocean that's covered by AFRINIC. We have been incorporated in 2005, as I just said. And today we have we are close to 2,400 members. Okay, we have close to 2,400 members. Now, how AFRINIC is governed? So AFRINIC is governed by 9 directors. So we have a board of directors, and this board of directors is made of 8 seats, as you can see. So Africa has 6 regions: the north, the south, Central, East, West, and Indian Ocean. So we have 6 regions. And we have 1 seat per region. And we have 2 seats that are non-regional. Seat 7 and seat 8. And then the seat 9 is the CEO, who is going to be recruited by the directors. So when the directors are elected by AFRINIC members, they are going to recruit the CEO, and the CEO is going to sign my contract. Okay? And because we are a community, we have many other committees that are helping the directors to run the organization. So we have the nomination committee. The nomination committee, when we have like an election, for instance, the election, the board of director election that we are still trying to organize, we have a nomination committee that is going to receive all the applications, and they are going to publish the finalists of the selected candidates for that was to stand, okay, that compete to be director. We have the election committee that is basically made from staff. So we are doing administrative function when it's come to the election. We print, we do website updates, etc., etc. We help candidates we help their community to organize their election. Good. And we have also the members that are there, and we are going to talk about the members later. We have the Council of Elder. So they are made there. We have like the former directors are there to advise the current directors. Okay. And they should not exceed 6, I think, 6 members, 6 or 5 members. They should not exceed that. Okay. And the directors are like 4 committees. We have the audit committee, finance committee, remuneration committee, and technical committee. So they divide, they see, and they also call like committee members to be part of the other committees that I've just discussed about. Now, AFRINIC membership. We have 3 types of membership. We have the resource members that are internet service provider. So basically, when an organization uses IP addresses, is using IP addresses to make money, it's qualified as resource member. It's qualified as resource member. Now we have a registered member. Registered members are directors. As soon as you are elected, you are a registered member, and you have associate member. Associate member can be organization or individual, like Facebook, like organization, TikTok, those organizations. And if you want to be associate member, you submit your request to the director. They are going to evaluate and tell if you are eligible or not. So we have 3 types. So basically, the university, the banks, all those organizations that use IP to connect the network to the internet are classified as resource members. And here as well, we have subcategories. Like I'm not going to put a bank or university on the same basket that an internet service provider. So they're not the same. So we differentiate the type of resource members. But the thing that you have to remember now is that AFRINIC has 3 types of membership. And now, if you want to talk to us, if you want to send an email to us, we need to register to those mailing lists. It's very important because, as I said, we are playing a crucial role onto the internet. So we need our community to be there with us to help grow internet in Africa. So you can also snap it if you have like your phone, that it will direct you to this link where you will find all the available mailing lists that we have at AFRINIC. And it's very important. So that was some, AFRINIC at a glance. Now let's go back to what we have, what IPs are managed. So ICANN, I just said, will issue some block of IP over its IANA function. Okay. So the IANA function of ICANN is going to give some IPs to the area. It's going to allocate some block. So we are going to receive /8 IPv4 /12 IPv6 and some block of ASN. That's for V4 and that is for V6. Okay. So ICANN over its IANA function. So the IANA function is currently performed by the Public Technical Identifier, PTI. We had something called the IANA transition. And at the end of this IANA transition, we have agreed that a public technical identifier is going to run the IANA function. So now the IANA function is being run by the PTI. And so it's going to give us, like, as I said, those different blocks. And AFRINIC, APNIC, ARIN, LACNIC, and RIPE-NCC are going then to manage regionally the block that they received. Okay. So we are going to do assignment for end user. So we are using this term. We differentiate allocation from assignment. It's, if you have question about it, I can explain why we dissociate them. So we have assignment that there for the that wants to use IP, the public IP for their network. But allocation is for organizations that want to use those IP to make money. So they want to have the possibility to do sub-allocation or sub-assignment, etc., etc. There are things that when you are a university or a bank, you don't want to do. Okay, you don't want to do. So this is why we don't have, like, we have assignment and allocation. So in one word, PTI or IANA is giving some block of IPs to areas, and areas are doing the sub-allocation or sub-assignment to the different members. And for members that get allocation, they can also do sub-assignment and sub-allocation for their clients. So this is it. So now let's talk about some statistics. So in IPv6, in terms of /8, Africa got like 7/8. Okay. APNIC got 53/8. North America got like 99/8. LACNIC 11. And RIPE-NCC, the Europe region, they got 49/8. As you can see, Africa was the last one, and we got the remaining one is not like they decide no, Africa is not going to have IP. No, it's just because we came late in the game. So there is a reason why we got a few IPs number. And the last 5/8 were distributed, one per area. Okay, and it was around I think 2012 when IANA has shared the last /8, the 5/8, and from there IANA tell the community that we don't have IPv4 anymore in our pool. So now if we want IP, of course we have to go to your different regional registries. And this now today, what we have today, we have AFRINIC and APNIC, where we can still have IPv4. ARIN has exhausted its IPv4 block. Same for LACNIC, same for RIPE-NCC. So now only APNIC and AFRINIC have IPv4 addresses. Now let's continue with statistics. So how many IPs do we have? We have today in Africa, this is what we have. 908,032 IPv4 addresses for all Africa. 900,000. It's just nothing. So to have an internet service provider wants to start operations in Ghana, it's going to be impossible for him to get like one IP per customer. It's just impossible when it's come to IPv4. So we have like these days the 2,341 members, and member with IPv6 we have 1,320 members that's with IPv6, and we have allocated 436,992/24s, and we have located 2,502 ASN. So this means that in Africa, when you go to the internet, you can only see that in Africa we have 2,500 networks. This is what this means. When in the other region we have like 100,000 of network, in Africa we have only 2,000 networks. This to tell the penetration rates in Africa. You have a rough idea of how internet growth is in Africa. Now, still in the assertion, this is what we have. So we have like the updated version that I just sent. So this is time for us to deploy IPv6. As you can see, IPv4 have been exhausted, completely exhausted. As you can see, we have less than 900,000 IPv4 addresses for this Africa. So IPv4 was there for a while. Since 80s, we have IPv4. Now we have exhausted IPv4. It's time for us to move to IPv6. Now, so this is some statistic on IPv6. Now let's talk about the IPv6 adoption in the world. So you can see that it's green, 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 green everywhere. But when it comes to Africa, we see that we have a lot of white. So this means that we have a lot to do in Africa. Let's focus on the West. So it's Ghana, where we have 70% of IPv6 adoption. Are doing good. But the good is that every year we have countries that want to get IPv6 working in their country. So this is something good. So today we have a lot to do, but year after year we are seeing more network IPv6 is ready. And this is the web content in the continent. As you can see, we have some content that are available basics. But remember, those content are not stored in Africa. So it's African content, but available over IPv6 in outside Africa. So this is why we have to take this, So we have content, but this content is available in Europe or in America over IPv6. And web content in the West. So this is it. As you can see, we have a lot of web contents that is green, that most of the website that we are having are available in IPv6. But if you want to connect from your network to that website, this website is going to respond only in IPv4. So it's not an IPv6 class, but we can plan that maybe another time of next year where we're going to do a class on IPv6 to tell that when a device is requesting a website, you're going to ask for IPv4 and IPv6. I want to connect to AFRINIC.net over IPv4 and IPv6. AFRINIC, if your device can speak IPv6, the DNS will provide the IPv6 address of the AFRINIC website. But if your device cannot speak IPv6, it's going to receive only the IPv4. So this is how the thing's working. Yeah. So this is the web content. And I'm going to, that is going to be the last slide that I have for this IP number management. Why is it important for Africa to deploy IPv6? The first point that I put here is the internet penetration rate. Internet penetration in Africa is low, and we have a lot of discrepancy in a country to another. Even in each country, for instance, in Ghana, the internet rate is not the same compared to Takoradi, compared to Tema, compared to you see, to Kumasi, etc., etc. And this is the case in Cote d'Ivoire. This is the case in Liberia. This is the case in Nigeria. This is the case in Morocco, etc., etc. So we have an acceptable penetration rate in the capital city, but when we are moving far from the capital city, you see that the internet penetration is dropping. And this means that there is a lot to do. If a new internet service provider say, hey, I want to touch those regions that are not covered, it's not going to have enough IPv4 to do that. And it must use IPv6 then. So this is the first thing. And the second point is that the internet is a UBG site. Like we have a lot of opportunities. We have many things to do in Africa. We have, so when organizations want to start a business, for instance, when the big Chinese are there everywhere in Africa. When they come, they want to connect to the network back in China. And as we see, AFRINIC, they don't have enough IPv4 to do that. So they want to use IPv6. So your country must be IPv6 ready if you don't want to lose those opportunities. Before I want to set up my business, I need to connect my server that speak only IPv6. And I'm in a country where I can't find, an internet service provider that can give me internet connectivity access over IPv6. I'm going to leave that country. I'm going to look for another ISP, etc., etc. But definitely, not, it's definitely it can. It's definitely an obstacle, a barrier for your country to toward those opportunities. And today we are talking about cybersecurity, and wants to do who is doing what on the internet. We want to identify each person that is using the internet, and this is very impossible with IPv4, as we yet see. We don't have enough IPv4 to do that, so we don't have any choice that to use IPv. And in countries like Cote d'Ivoire, for instance, I don't know, many countries they regulate that each internet they must be identified or to assign a quick IP address to each of their customers. And it can be done, it can't be done with IPv6. So we don't have any option that using IPv6. And it's very unfortunate, but it's true. We are technology consumer. We don't create that much in the internet, in the internet ecosystem. We don't create that much, and so we need to be ready when Facebook will just stop IPv4, or when Google will stop IPv4, YouTube will stop IPv4, because they are operating, they are running two different stacks. We have an IPv4 stack, we have the IPv6 stack, so they are running two different stacks. And when you check to the global map, you see that America, Asia, Europe, and Australia, they are ready. So we see a lot of blank in Africa, but they are for the other they are ready. So if one day they decide to stop using or stop maintaining IPv4 stack, we're going to be in the dark, and it's something that we don't want. If I'm an internet service provider, I don't want my customer to be prevented to access those GAFAM. So I have to do my best to ensure that they have access over IPv4 and IPv6 to those big internet organization. And another thing is the opportunity for us to switch from technology consumer to technology creator, because IPv6 is quite new. It has been created in 1986, 80 and 1988. So that the first we're starting talking about IPv6, but before IPv6, we're talking about IP next generation. So if you are Googling or if you are doing some research on IPv6, you see that before talking about IPv6, we have IP next generation, etc., etc. Those were working since 1992. Since 1992 on the successor of IPv4, because we realized that with the class full addressing system, we are going to exhaust all the IPv4 pool, the B class pool in 1992. So since 1992, we started working, ITF started working on the successor of IPv6. So today we have the opportunity to create something related to improve, to invent something related to IPv6. And as I just said, as technology consumer, you must be ready when giants will stop the IPv6 stack. So this is where I will stop. So elements, the backbone, the they call the internet resource numbers, IPv4 IP system numbers, and I spoke about the DNS. And then I explained how those IPs are managed. I said for this area system, regional internet register, we have 5, and each of them are receiving IP block, autonomous system range, from the IANA function that is currently run by Public Technical and Identified PTI. And then we have exhausted almost all the IPv4 blocks, and now we are issuing IPs from the IPv6 block. And it's very important for Africa because we need more IP to develop internet in Africa. So I hope it was informative for you. So now I want to give the floor back to the moderator for him to take question if you have question. Thank you.
Thank you so much, Brice, for that insight. We really appreciate. And I think we have a few questions to take. So,
Okay, thank you.
Um, Thank you very much, Mr. Abba, for the wonderful
you.
presentation. I've really learned a lot. My question is like a twin, Slit and Kaba. So the first one is due to the complex nature of the IP version 6, most organizations in Africa, especially in Ghana, rely on the IP version 4.
Yeah.
I want to find out if Africa is adequately prepared for IP version 6 adoption, and then what are the risks of falling behind? And then the next question is, how can African internet providers work together to stop things like spam, cyber attacks, and phishing attacks that uses IP addresses? Thank you.
Okay.
Should we take that, or should we take another one? Or you
Yes, take another one. I'm
Okay.
trying to write them down so that, yes.
Okay, thank you for your presentation. Well done. My name is Ola Bingpe. I would
Yes.
like to ask, you were talking about the traffic in US and Europe being responsible for the heavy cable connections we have in those regions.
Okay.
And you were talking about, I don't know if I'm using the right words now, the hubs of this traffic. So will you say that's what is responsible when it comes to roaming, that you will be in a region and you are roaming, and your roaming rates wouldn't be as expensive while roaming in another region? Take, for instance, you are in the US, you are roaming, and the rates you are charged is less expensive than when you roam in your own continent in Africa. Like, take, for instance, I'm from Nigeria. I'm roaming now in Ghana, and I mean, I've never roamed like this in my life. I will roam in the US, and I mean, it's just cool. It's like normal, but it's like extremely, extremely high over here. So, how will you explain what is responsible for the disparity we have?
Okay. Thank
Okay, I think let's take the third one. Then
you.
we
Yeah.
can.
Hi. So I have quite a few, but they are closely related. So my first is you mentioned that tier one is not regulated. They do whatever they want based on however they feel. But tier two and three, you did not you mentioned that they are regulated, but I do not know the regulatory agency that is in charge of the tier two and three ISPs. Then, which countries in Africa currently have the internet exchange point set up? And follow up to that one is it possible for government to set it up? Maybe because of the extremely high cost in setting up these internet exchange points, and whether that could be a very good way in order to reduce the overall data charges that are that they incur whenever they use it. Yeah. I think the last one was answered when you showed the chart about the IP versions that are currently assigned. Because I was going to ask about whether they are assigned based on volume that are exhausted, or they are being assigned just by usage on the continent. Thank you.
Okay, I think there is. Or will you take this three before we go for another round?
I don't know. Let's take. Do we? Let me take that one and we go for another round.
Okay, okay, sure. That's good.
Okay. Well. No, question number one. So we wanted to know. The question was related to the if the complexity, of IPv6, and if Africa was like ready to deploy IPv6. So what I will say that IPv6 deployment, IPv6 per se is not something that the the population may know about, or may know like must be maybe master like guru about, you know. The problem of IP numbers are things that must stay at the internet service provider side, because me as internet user, I don't care. I don't know whether I'm using IPv4, IPv6 to browse. When I want to go to Facebook, I want to go to Google, I want to go to YouTube. I just want to be connected. I just want to have a good experience. So my internet service provider is the one who's going to bother about, is that IPv4, is that IPv6. Now, if I'm a new internet service provider, the reality is that I can't have enough IPv4 to connect all my clients. Then I must go to IPv6. Then I have to be ready to do that. So in terms of devices, we have already in Africa since like 2020, 2000, and since 2000, we have a lot of uh, vendors that started working on IPv6. How would I put in IPv6 support? So the level of IPv6 support on the devices today has increased a lot. So many devices that we are using are IPv6 ready. Our TVs, our phones, etc. etc. So today it's just like we did a survey in 2018 where we're asking the technical community why they are still slow in deploying IPv6, and the first reason was we don't have the buying from our bosses. So my boss can still browse internet, so he doesn't understand why you guys are talking about IPv6. He doesn't know what is IPv6, so he doesn't care per se. And option number two was like, well, IPv6 is we have like I'm not comfortable doing it alone. And number three is that I have devices that cannot support IPs. So based on that, we have three like type of workshop for them. IPv6 or decision makers, a DO help desk, like a deployment operation help desk. And number three is that transfer mechanism to assist our community in Africa to deploy IPv6. Today, we are assisting people who want to deploy IPv6 for free. So if you're AFRINIC member, you want to deploy IPv6, we are going to do it for free. We are going to assist you. If you want to make it done, we are going to take you there. So Africa is ready to deploy IPv6. So it's just like people need to start at some point and they, do things. So number two is, can ISP work together to mitigate all attacks related to IPs? Yeah, as a regional internet registry, we are putting in place some security tools to make the routing more secure. And we have what we use at time the internet routing registry. And today we are using IPKI, Resource Private Key Infrastructure. That is a technical security system that we put in place to help our members to secure the resources. That today, when you are issuing your resources, when we issue a resource to our member, we assign a certificate to this resource. So this member can create what we are calling a route origin authorization. So you say that I'm MTN in Ghana, I'm operating from Ghana, and this is the IP block that I've been assigned, I've been allocated from AFRINIC, and I'm going to paste my certificate on my IP block and send this block to the world and saying that this block belongs to me, and this is my certificate to approve that, to attest that this block belongs to me. So I try to simplify how the API is working, but basically we have assigned a certificate to each resources that we have, and our members need to just, let's say, activate their RPKI in the network. And this is going to make the routing more stronger. And this how we these are some of the tools that we put in place to mitigate the cyber security issue related to IP numbers that are very critical. We have many examples where we have traffic that have been rerouting, traffic that have been hijacked, etc., etc. So those measures are very important to ensure that IPs are used by the owners, by the owners. And another question was the traffic between that roaming shipper, because okay, roaming, when we're talking about mobility, mobile phones, and so on. So roaming is like consensus. So it's policy. In technical part, we know how to do it. It's not a big deal. Now we need to agree that between ECOWAS, for instance, we need to set up a rule saying that, oh, when I'm in ECOWAS and I'm moving from Ghana to Cote d'Ivoire, from Cote d'Ivoire to Nigeria, etc., etc., this is the fixed rate that we are going to use. So the issue is not technical. The issue is policy. So I hope it's clear. So it's policy. So roaming is policy. So it's not like, yeah, because when you have your phone, the tier three, they knows how to do it. They know how to take your number from a network to another one. They know it, but the thing is, they are making money out of it, so they don't want to agree to a fixed rate. So this is the problem. In the Europe, in America, they have strong institution and they force them to fix the rate. For instance, ECOWAS said we should have a fixed rate when it's come to roaming, but this rate is never applied. Never applied. So this is a policy issue, not technical issue. And the last question was the last one, blah blah blah. Okay, so I was saying that okay, the tier three, tier one and tier two are the ones that are working on to set up basically the tier one are the one that are building the backbone. And we have the tier two that are between the tier one and the tier three. So the tier two are buying bandwidth from the tier one and selling this bandwidth for the tier three. So the regulator, the ICT regulator of Ghana is the one who regulate the tier threes in Ghana. The tier threes in Ghana are the MTN, Vodacom, Globalcom. I don't know if you guys have Orange in Ghana. I don't recall. I've been there for a while in the past, but But those internet service providers that we have in our countries are them that we call tier three. And most of the tier threes in the country are regulated by the regulation authority that we have. I don't know the name of the regulation authority in Ghana, but we have in Cote d'Ivoire, it's IRPCE, we have IRTP, we have, regulatory body are this organization that are issuing license to telecommunication, etc., etc. So this is the body that regulates the tier three in our countries. But the tier one and tier three, we the tier one, sorry, and the tier two, we don't have like an organization per se that is regulating this. I hope I was clear enough. Okay, the last one, how IPv6 are being assigned. So remember that I say every IP that we are assigning or we are allocating to a nation is based on constitutive manual, the CPM. I'm going to put links. So we have rules written by T, and we are using rules. So basically, is need, based on need basis. So I have based on basis, IPv6 basis. In IPv4, we used to be in need basis, but because we are we have almost exhausted the IPv4, the community say, okay, AFRINIC, when will we start assigning your IPv4 from your last /12, you have to trigger what we are calling the soft landing policy phase 2. So SLB2 is a policy that have been proposed by the community that say that when you guys will start assuring IPv4 from your /12, the biggest block that you can assign is a /22, and the smallest is a /24. So this is today you cannot have like /20, /21, /19, etc., etc. The biggest that you can be assigned is /22. So it used to be for IPv4, it used to be need basis, but now it's based on the soft landing policy too. But in IPv6, it's still on need basis. If you need a /14, if you need a /20, we are going to give you this block in IPv6.
Okay.
I hope my responses were clear enough.
Yes, yes. Thank you so much. But I think you skipped one question from the last person who spoke.
Okay, yes, please.
Regarding the internet exchange points. So he was asking.
Oh, yes. Yeah. Oh, yeah. Okay, internet exchange point. We have like 3 types of internet exchange point. We have government internet exchange point, governmental internet exchange point. We have university educational internet exchange point, and we have community and so government set up. And internet exchange points is not very expensive to set up. if one's more sophisticated, can, but in the beginning, it can be something very, 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 very simple.
Okay.
So we need a switch,
Okay. Hello.
a limit,
I think
where
I think his question was on which countries have it in
oh
Africa,
yeah, yeah, that one.
and can the governments also set it up?
Yes, we have. Let me see if I can find the list. We have Ghana has an internet exchange point.
Oh, okay.
Ghana has one. Yes, Ghana has one. You have Cote d'Ivoire. We have Benin, Togo. They are still. We have like Nigeria. Have like more than one. We have yeah, many countries in Africa where we have internet exchange point. In the way I think that we have less than 4 countries. We have Liberia. We are trying one in place. In Conakry, they have one, and I will be there next week to do some work with them on regarding the internet exchange point. So yes, and as I said,
Oh, yes. We can't hear you now. Please hold on. Hello, Brice. Please hold on for us. I can hear you on Zoom, but we can't hear you
another
here.
pop Europe, with that's the
Hello,
first
Brice.
created building they are going to have another access point, another pop there. So we have many countries in Africa that have internet exchange point, and you can see the price of internet is dropping now in Africa because they are reducing the use of the international link. So I don't know if I've responded to all the questions now.
Okay, thank you so much. So let's
Over to
quickly
you.
take
Yeah.
the last round of questions. We'll take three
Okay.
more, then we can.
Thank you very much. Albert here. So, straight up, what strategic approach can AFRINIC adopt to ensure that African digital data is recognized, valued, and requested by stakeholders, especially in Europe and US? Looking at the diagram that you gave us, that we have a lean traffic, exchange. So please, I really need it.
Okay, so the next person, please let's make it brief as well.
So my question is, how is AFRINIC ensuring that underserved regions are not left behind?
Okay, so the last person.
Okay, thank you, Bryce, for your presentation. I have two questions. You showed a diagram, and in the diagram, you showed the subscriber connecting to the ISP core, and then from the ISP core to a point of presence or CDN, then from the point of
Yeah.
presence to the tier one. So I want to understand if, for example, MTN Ghana decides to build its own exchange point, and then they decide to place the exchange point in, let's say, Togo. You know, there's a route from Togo via Volta region to Tema. So will that be classified as an exchange point? Because you mentioned exchange points are routing content locally. So if it crosses the borders of the country, even though there is a direct route from MTN to MTN between the two data centers, they are both MTN. Can we still classify that data center as an exchange point, or once it crosses the borders of the country, technically it ceases to be an exchange point? And then my second question. Hey, I've written it somewhere. I think I'll come back.
Okay, so yeah, over
So
time,
we
but
good?
Brice, please go ahead.
Okay. Related to what's the effort that Frank is putting in place to ensure that we have more links coming to Africa. So I think that it's what we are doing is advices that we are giving to our members. we encourage our members to store the data in Africa. This is what we do, and we ensure that the IPs that we are issuing are being used in Africa. So Nigeria did something great where so last year, I mean, they said that everything as a government must be stored in Nigeria. And before it was email system must be stored in Nigeria. Now they have everything related to government, everything, even web must be stored in Nigeria. And so all those data that were stored in, like in that were stored in Nigeria. So as you can see, this there's a reason why once Netflix is there, there's a reason why they realize all those content that used to be there are now in Nigeria. So they realize they have to come in this. So it's again policy because the technical we know how to do it. So governments, we need to have to have to get agreements where we decide to keep all those our the content produced by Africans and that are kept outside Africa comes come back to Africa. This is the only thing that we can do to impose them to be more capable to get those data that are here in Africa. And as AFRINIC is not active in the routing, they want us to remain in our function of managing IP numbers. We are ensuring that all those IP are available, but at the same time, we encourage our governments to create a policy that help them to keep local all the data that they are producing. And how can we ensure that nobody is left behind or any no country is left behind? We have what we are calling the Africa Development, the Internet Development Program. So Africa has a big program with 6 pillars where we are giving fellowship, where we are giving fund for education, where we are giving fund for critical infrastructure. So we have this Internet Development Program initiative where we are helping our community members. So we plan to go, for instance, in countries like Liberia, in countries like Sierra Leone, in countries like Central Africa, where we have like a big gap compared to other countries in the West. So we have program, dedicated to these countries that's where internet is less. So in 2012, I was one of the staff working with Chad to help the technical community grow. And today we can see that they are present everywhere. They are pushing, and it's what we want to do with Liberia, with Sierra Leone, and Central Africa as well. So we have programs like Internet Develop. If you Google Africa, AFRINIC Internet Development Program, you see that we have 6 pillars where we are also touching with women's in ICT. We are tackling also people with disability, etc., etc. And the last point is related to Internet Exchange Point. So Internet Exchange Point is an infrastructure where we have layer 2 infrastructure. It's a layer 2 infrastructure. We have regional internet exchange point, we have national internet, etc., etc., etc. So an internet exchange point is valuable when we have 2 connected. If like the minimum is 2 or 3, if it's the same option that it's just it's nothing to do with the net exchange point. So this all pop everywhere. LGBT pop everywhere. It has nothing to do with internet exchange point. Internet exchange point is like we have many tier 3. We decide to connect to ensure that local traffic of our customers remain local. Okay. So I hope it clarifies. So everything related to a single operator is growing its network. Is that okay?
Yes, please. That is very perfect. Thank you so much for your insights, and I think we really appreciate you for your time. And I think Brice Abba has been with us for the past 6 years, and we acknowledge you for that as well, for always responding to our call to share your insight with us.
I'll be with you.
We really thank you so much. God bless you. Bye.